Hey everyone, welcome back to Drill Coding. This is part 7 of our top 10 Java interview question series. And today we are covering some hidden and advanced Java concepts that can impress any interviewer. So let's get started. Alright, let's talk about method hiding in Java. When subclass defines a static method with the same signature as a static method in the superclass, it's called method hiding. Unlike method overriding, which works for instance methods and uses runtime polymorphism, static methods are resolved at compile time, not runtime. Let me show you a simple code. So we define a class parent with a static method greet, and a child class extends this parent class, and here we define another static method greet with the same signature, and this hides the method from the parent class rather than overriding it. In the main method, we create a reference type of parent but object type of child. And when we call object.greet, then it will call parents greet method instead of child greet. And here we are creating reference type of child class and object type also child class, and with the help of this object we are calling this greet method. Then it will call child greet method. Since it's a static method, Java resolves it based on the reference type, not the object type. So that's all about method hiding. Second question is, what is the purpose of System.gc and how does garbage collection work in Java? In Java, memory is managed automatically using garbage collection, which reclaims memory used by objects that are no longer reachable. System.gc is a request to the JVM to run garbage collection. But remember, it's just a request, not a command. Let's understand it with code. We define a garbage demo class here with a finalize method, and inside the main method we are creating the object and then set it to null, which makes it eligible for garbage collection. And then we call system.gc. This tells the JVM that it might be a good time to clean up unused memory. It will call finalize method on the object before deleting it, and that's when we see the output. And keep it in mind that Java 9 and later versions discourage the use of finalize method. Let's see next question. What is object cloning in Java? Object cloning in Java means creating an exact copy of an object with the same field values, and Java provides a clone method in the object class. To use it, a class must implement the clonable interface. Let's take a look at code example. We define a student class here and it implements clonable interface, and we are taking two variables here, int id and string name, and this is the constructor here, and here this is the clone method. It calls super.clone, which creates a shallow copy, and inside main method we create s1 and then clone it to create s2. Both objects now have the same data, but they are different instances. So always remember, Java's default cloning is a shallow copy, and for deep copy you'll need to override clone method and copy nested objects manually. Let's see next question. What is the difference between comparable and comparator interfaces? Java provides comparable and comparator interfaces to help us sort objects. Comparable is used to define the natural ordering of class, and comparator is used to define custom ordering, often externally. Let's look at the example. Here student class implements comparable interface, and we are taking two variables, name and marks. This is constructor, and here comparator defines natural ordering by marks. Now for comparator, this comparator sorts by name, and we can use it with collections. So in short, use comparable for default sorting and comparator when you need custom sorting logic. What is the difference between shallow copy and deep copy? In Java, a shallow copy means creating a new object, but the fields inside it still point to the same memory references, and a deep copy means you create a completely independent copy of the object, including copies of the referenced objects inside it. Let's see code example of both. Class address is just a helper class with a city field, and this is the constructor of this class, and here we create another class person, which implements clonable interface through which we can use clone method, and calling super.clone here makes a shallow copy. This means object p2 gets a new person object, but the address reference is the same. In main method we created this object p1 with address Delhi and cloned into p2, and here we changed address of p2 to Mumbai, and output will show both p1 and p2 have Mumbai because they share the same address object. So in shallow copy, object references are shared and changes reflect in both. Let's see deep copy example. Here we have this class address DC, and we added a copy constructor to create a new address object with the same city, and a class person DC implements clonable interface. Here super.clone method copies primitive and reference fields like shallow copy, and then we replace the reference with the new address DC object, ensuring it's not shared. And in the main method we created P1 with Delhi address and cloned into P2, and then we change address of P2 to Mumbai. So in this case we will get output Delhi as P1 address and Mumbai as P2 address. This is because both have separate address objects. In deep copy, all referenced objects are also copied, so changes don't affect the original. Sixth question is, what is the use of transient keyword in Java? When an object is serialized, all its fields are saved unless a field is marked as transient. We can say that transient keyword tells Java that do not serialize this field. Here's a simple code example. We have this user class which implements serializable interface, and it have two fields, username and password, and here we marked password field as transient. Now when we serialize and deserialize this object, username will be restored but the password will be null, and this is useful for sensitive fields like password or security tokens that you don't want to store in files. Moving forward to the next question. What are static blocks in Java and when are they executed? A static block in Java is used to initialize static variables, and it runs only once when the class is first loaded into memory. In this example, we created a class main, and here static block sets the static variable value, and when the class is loaded, the static blocks runs before the main method. So you'll first see static block executed and then main method executed. Static blocks are great for complex static initializations or loading configurations. Let's see next question. Difference between checked and unchecked exceptions. So checked exceptions are checked at compile time and must be handled using try catch or throws, and unchecked exceptions occur at runtime because of programming errors. So in this example, file not found exception is a checked exception. You have to handle it using try catch or declare using throws, and arithmetic exception is unchecked exception. Here it will compiles fine but fails at runtime. Can an interface extend another interface in Java? Answer is yes. In Java, an interface can extend one or more interfaces, and this allows us to build flexible hierarchies of behavior. Let me show you an example. We have this vehicle interface, and here car interface extends this vehicle interface. So it inherits method start, and here sedan class implements car interface. So it must provide implementation for both method start and drive. And here in the main method, we are creating object of sedan class and calling here start method and drive method. This is similar to class inheritance, but in interfaces, multiple inheritance is allowed. Difference between composition and aggregation in Java. Both composition and aggregation are types of association in Java, and they are representing has a relationship. Composition is a strong relationship. If the parent dies, child dies too. And aggregation is a weaker relationship. Child can live even if parent is gone. Let's understand with code. Here engine is tightly bound to the car, and if car destroyed, engine also goes. This was the example of composition. Let's see aggregation. Here student and department can exist independently. So if we delete student, department still exists. So composition is tightly coupled and aggregation is loosely coupled. So this is all about today's video. If you found this video helpful, then do subscribe and also hit the like button and share it with your friends. See you in the next part. Keep coding and keep learning.